All right, in this video, we're going to start section 4.5 on graphing sine and cosine. This will be part one. We will follow it up with a part two. So to get started, what I'd like you to do is complete a table of values that we're going to expand upon. But for now, what I'd like you to do is fill it out for the function f of theta, meaning the input is theta and the output is whatever the sine of theta is, on our known points from the unit circle between 0 and pi. So I'd like you to pause the video and give it a try and then come back and check and see what you've got. All right, so I'm going to do this as quick as I can. I'm going to make myself a fairly large table of values where my input is going to be theta and my output is going to be f of theta, or in this case, whatever the sine of theta is. So I'm going to try to do this from memory without drawing the unit circle. So the sine of 0 is the y value. So that is going to be input of 0, output of 0. The sine of pi over 6 is going to be the y value on that, which is a half. And then I've got pi over 4, which is the square root of 2 over 2. And then I've got pi over 3, which is going to be root 3 over 2. And then I've got 90 degrees, or pi over 2, and that is 1. Then I move into the second quadrant, so I guess I will go ahead and throw this circle on here because I can make my life a little bit easier. Because I know then my next value of 2 pi over 3 is going to be the same answer that we got for pi over 3. So that's just going to be root 3 over 2. And pi over 4 is going to have the same answer right here for 3 pi over 4. And so that's root 2 over 2. And then 5 pi over 6 is going to have the same answer as pi over 6, so that's a half. And then pi is going to be 0 again. Okay? So what I'd like you to do is continue making this table. So we're going to keep this table rolling. But this time, let's just do the following inputs. So theta and f of theta still. Let's start off where we left off, but this time let's just jump down and do, let's do pi over, what are we going to do here? Let's just do 3 pi over 2, and let's do 2 pi. Let's see. You know what? Let's do a little bit more than that. My apologies. Let's go back and let's go ahead and do one more quadrant with the same values. So we're going to go to, leaving off at pi, so we're going to be at 7 pi over 6. And then we're going to be at the 45 degree, which is going to be, what, 5 pi over 4? And then we'll do, was it 4 pi over 3? And we'll do 3 pi over 2. And I think then maybe we'll just kind of jump down and do 2 pi. That should be enough. All right, so 7 pi over 6 is going to be the same answer as 5 pi over 6. And so we're going to be a half, but this time it's going to be negative. And this is going to be negative root 2 over 2. This is going to be negative root 3 over 2. And then 3 pi over 2 is going to be negative 1. And then, since the values will be the same, we would just have the same values repeated as we walk our way back down to 2 pi. So we get these values. Now, if we wanted to keep going, we could, but we know that as we started off with the next value, we're going to start getting the same values we got again. So it's just going to repeat. And so no matter how many times you go around the circle, we would just keep repeating all the values that we have here. And if we went in the negative direction, we could fill that out as well and do negative thetas, and we would just get the same values again, just going the other direction. So now what we want to do is we want to take this table of values and we're going to translate it to a coordinate graph, so an XY graph. So here we go. So now we want to graph sine of theta. So the first thing I'm going to do is try to draw a straight x-axis, or theta axis, I guess it would be. There's your input. And then I'll go ahead and put my output right here, which you could label as y, I suppose, or f of theta. And so I'm going to go through and mark this as accurately as I can, but I got to make sure I'm consistent in my values. And so this is going to be a little bit tricky because I've got some gaps here, right? So this is going to degrees, this is a 30-degree gap. This is a 15-degree gap. This is a 15-degree gap, and then another 30. And so if I just need to be careful about how I graph this. So let's do the following. We're going to do some estimating. We'll just do pi over 4. We'll go by increments of pi over 4. So I'm going to jump, and in class I might do this differently. Let's call this pi over 4. And then this would be pi over 2. This would be 3 pi over 4. This would be pi. 5 pi over 4. 3 pi over 2. And 7 pi over 4. And 2 pi. And I could keep going, but that should represent going one time around my unit circle. And so now let's transfer our values, and I'm gonna, just so it doesn't look so tiny, I'm gonna just use a scale of, I don't know, like I'm gonna use on mine three grids here. No particular reason. I just want to make sure it's of decent size. All right. In fact, I'm gonna, for reasons that'll make sense in a minute, I'm gonna do 4 grids. So I'm gonna say this is 1, 2, 3, 4, and this would be the -1. All right. So referencing our table of values that we created, let's go ahead and put our points down. So I'm going to do the easy points first. So sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. The sine of pi over 4 is root 2 over 2. So we have to estimate what the heck that is. So the square root of 2 over 2, if you check it on your calculator, is about 0.707. So halfway between, let's see, this is, if I'm going by grids of 4 here, then this would be 0.75. So I'm just going to be slightly under there. So pi over 4 is root 2 over 2. And 3 pi over 4 is also root 2 over 2. Stop it. And then we know that the sine of pi over 6, which is not halfway between 0 and pi over 4, right? Pi over 6 would not be halfway. It would be closer, because this is 45, so then halfway, that would be pi over 8. That would be, what, 22 degrees or so. And we're looking at 30 degrees. So I'm just going to estimate. I'm going to just scoot it over a little bit. And I know that, so a little bit there is going to be a half. And if I go, again, not a full over here, because that would be another 22.5 degrees. We're only going 15 degrees. So then that would be root 3 over 2, and that would be, let's find out. What is the square root of 3 over 2? And actually, now I'm worried that that's the 0.707. So let me find my calculator. Excuse the delay. I wasn't prepared for this. All right. The square root of 3 divided by 2. Okay. So that is approximately 0.866. So I would say right about here, we're going to be right about there. And then that's all going to get matched on each side. So this would be the same. And we would be about halfway. Ooh, what's going on here? Halfway here would be a half. This is pretty ugly, and I hopefully will do a better job in class, but it looks to me like we have a graph that looks about like this. And once again, at 5 pi over 4, so halfway between the 0 and the negative 1, we're going to be about 0.707. So that's going to be real close to here. And then a little bit in, we're going to be at a half. And a little same amount past it, we're going to be at 0.8 something. And so I get a graph that looks like this. Those get matched on each side, so I'm going to get a graph that looks about like this. And this is what's known as the sine wave. And we know that it continues because all of this represents one rotation around the unit circle. And so when I continue this, I'm going to continue getting the same values. So I could really just kind of copy and paste this red wave, and then I could just keep on going. Let's see, pi over 2 is how many? I counted that as 4. 1, 2, 3, 4. So this value here would be, let's see, 4 pi over 2. This would be like 5 pi over 2. And we'd be back up to 1. And so my second go around would look something like this. And then we would start coming back down, and then I run out of room. If we go in the negative direction, we would be getting the same values that these, let's do it this way. This is essentially like between here and here. Let's see, let me shade it here with highlight it. This highlighted section, that comes from quadrant 1 in our unit circle. And this shaded part right here comes from quadrant 2 in our circle. And then this is going to be quadrant 3, and this is going to be quadrant 4. And so if we just keep going with our graph, we know that, let's see, again, I've counted over by 4. 1, 2, 3, 4. So that's going to be negative pi over 2. But negative pi over 2 is coterminal with 3 pi over 2. And so we'll have the same y value, which would be down here at negative 1. And so this right here translates to our quadrant 4 from our unit circle. And then if we keep going in the negative direction, 1, 2, 3, 4 more, right about there, which would be negative pi, we're going to be back at 0. And so just to complete the image for anybody who needs it, from our unit circle, we've got our points here, and then we've got quadrant 2, and we've got quadrant 3, and we have quadrant 4. All right, hope that makes a lot of sense. So let's name this. Again, this is known as the sine wave. We would say that this is a periodic function because it just repeats. Okay, and a period is the length of time it takes to repeat, but the fact that it just repeats itself makes it known as a periodic function. So the period of a function is the amount of time it takes to complete one full cycle, and the period of sine is going to be how much. So if we go back and take a look at any point, how far do we have to wrap around, or how long do we have to go on our independent axis before the values just start repeating over and over again? And I think it's quite obvious that it's going to be between 0 to 2 pi, and so that is a length of 2 pi. So if you go from any point on this graph, so like if I take a look at, say, here at pi over 4, and I count over 2 pi, which would put me right here, we've got it's starting back over, right? So I just picked a random spot. If I took this top part and counted over 2 pi, we would be at the top part again. If we count over from 0, yes, I hit another 0 at pi, but I'm not repeating my graph yet. I'm repeating my graph when we get to 2 pi. So from any point, you add 2 pi to it, and you're just repeating, and that makes perfect sense if we just think about 2 pi being wrapping around the circle one time. So the period of sine is 2 pi, and one full period of sine, one full cycle, what we're going to do is we're just going to make this super easy. We are going to just mark the extremes. So we know we start at 0. We know at pi over 2, we're at 1. We know at 3 or at pi, we're back at 0. And we know at 3 pi over 2, we're down at -1. And then back to 2 pi, we're at 0. So one cycle, one period of sine looks like this. So we just round it off. And then if we know where the highs and the lows in the middle are, we don't have to waste our time. And you even saw me when I did this the first time, I was kind of fumbling with finding these values because they're kind of hard to locate. But I can get the general idea and be pretty darn accurate if I just focus on the highs, lows, and the middle. All right. So let's take that and let's go ahead and graph some transformations. So let's go ahead and take a look at these. Let's go ahead and graph sine again. And this time, I think I'm going to keep things really simple for myself. I could stick with 4, I guess. It doesn't really matter. But this time, I think I'm just going to go with 2. So I'm going to go here and say that this is pi over 2. I think I'm going to label them just way down here so they don't get in the way. So pi over 2. So this would be pi. This would be 3 pi over 2. And this would be 2 pi. So one whole cycle is going to be right there. Let's go ahead and do a cycle this way too. So 1, 2, 3, 4. So the way I've set this up is I've got 4 spots, right? So start at 0 and then 1, 2, 3, 4, corresponding with the 4 axis points. So let's go around a couple more times. And then this would be all the way to 4 pi. And let's go around this way. This would be -4 pi. And then just so it's not super tiny, although it will be still pretty small, I think I'm going to count this as like, I'll count 2 boxes as 1. All right, so let's graph sine. I know sine of 0 is 0. Sine of pi over 2 is 1. I know I'm back to 0. I know I'm at -1. And then at 2 pi, I'm back to 0. And then I just repeat. And I do it the other way. And now I just fill in my waves. Try to be accurate. Don't be so sloppy. Make sure you've got a nice rounded curve. And in fact, if I were to pivot this lower part and rotate it around, it should make like one complete circle. You know, if I was looking at moving that part over there, right? So it should look very circular in nature. Definitely not zigzags. Definitely rounded at the tops and the bottoms. All right, so this black one, this is f of theta. All right, so let's look at g of theta, and let's think about what we know about our transformations. So look at this, come up with your decision. What's going to happen to this graph of sine when I do g of theta? And your answer should be that the 3 on the outside of the function, and how do we know it's on the outside of the function? Because it's not inside of sine, it's not in parentheses. Look at h of 0 and you can see the difference, right? This plus 3 is clearly on the outside. So we know that that is going to do the same thing it's done all year long and shift it up 3 units. And then the question is, what is this number up front going to do? Well, that's going to do the same thing it's done all year. That's going to be a vertical scale change. So let's talk about the vertical scale change first. If all we had was a vertical scale change, then that's just going to change the height of my y values and it's going to double them. And so this should be very simple. My heights were at 0, and if I double 0, and my little clicker's not working, so I'm at 0. If I look at 0, 0, the y value is still 0, and so scale it by 2, and you're 0. At pi over 2, this point right here, this is 1, so it's just going to get doubled to 2. This will be back at 0. This will get doubled down to negative 2. And so all we would end up doing is stretching this graph. And the plus 3 is going to move the whole thing up 3. So here's what I'm going to do. I'm going to figure out where moving up 3 is. And hopefully I left myself enough room. I probably did not. 1, 2, 3. So here's 3. And what I'm going to do is I'm going to now do what I've done all year long is I'm just going to pretend that this is the new origin right here. So not an asymptote, just a little graph to help me. So I'm going to throw this on here just to establish where my new x-axis is. Then everything's going to be stretched double off of my x-axis. So let's establish where things are. So I'm going to use, I guess, green here. So I know at the x-axis, we're at 0. Then at pi over 2, I would be up at 1, but that's going to get doubled. So this would be at 4. So we're going to be up here at 5, and I did not leave myself enough room. So I'm going to be over at pi over 2 and up 2 for a total of 5. But the key is I'm up 2 from here. Then I'm going to move over 2 more. I'm going to be back at the axis, and I'm going to move over 2 more. I'm going to be down 2. So I should be down here at 1. Move over 2, back to even, over 2, back to the height, over 2, down 1, down 2, back down to the bottom, over 2, up 2. Let's keep going, over 2 and down 2, over and back even, over and up, even, and down, and even. All right, so now I'm just going to connect. And so now my sine graph is shifted up 2, and it's become twice as tall. and hopefully everything matches up. Okay. All right. We talk about this stretching, this vertical scale change. We have another name for it here. So vertical scale change is going to become what's known as our amplitude, or our wave height. So we call this the sine wave. The wave has a height, and that is measured from the middle. So we don't talk about the height being all the way from the highest point to the lowest point. We talk about the wave height, or the amplitude, being from the middle position to the highest or to the lowest point, in which case would be 2 units. So this number is always your amplitude. All right. Let's take a look at h of 0. H sub theta. H of theta. What's wrong with me? All right, let's do this one in blue. So what is this graph going to do? Well, the minus 3 is on the outside, so it's going to shift everything down 3. But we also have a shift of plus pi over 2 inside the function, and we know what that does. It's going to move it in the opposite direction, so it's going to go to negative pi over 2 and down 3. So what I'm going to do is I'm going to take, again, my x and y axis that's located right here, and I'm going to move it pi over 2 to the left, which would be right here. This is negative pi over 2. I don't normally label things down here. I just knew it was going to get really crowded, so I just moved them down here for this graph. Normally, I would just put them right at the axis. So I'm going to move over to negative pi over 2, and I'm going to go down 3. So I've labeled 3, or 1 unit, 2 unit, 3 units. So that would mean I'm going over and down, which should put me right here. So now my fake x-axis is here. My fake y-axis is here. And I'm not doing anything to the amplitude, and so I don't have to stretch it. I just need to graph exactly what we've graphed, but start it right there. So this should be very simple. We know it starts at 0, and then I go over pi over 2, and I'm at the high point. I go over pi over 2, and back at the middle, back at the low, middle, high, middle, low, and you get the idea. Let's go this way as well. And now I'll just connect my graph. When we do our graphs, unless it says otherwise, we're always going to do a minimum of at least 2 periods. And that can be kind of anywhere you want. It can be all positive. It can move in the negative. It can be a little bit of both. We just want to make sure we've established 2 full periods of the graph. All right, so this should be h of theta. And the top one should be g of theta, which is the wrong color, but there you go. All right. So I hope you see that this is exactly the same graphing we've done all year long. Establish what the parent function looks like, and then move things according to the rules that we've used all year long. All right, let's move on, and let's take a look at one with maybe everything going on here. So once again, pause your video and establish what you think is happening, and then check back in. All right. For me, I'm going to first set up my graph, and I'm going to kind of always stick with the pretty traditional, because I don't want my graph to be tiny and hard to see. So I usually will use like 2 units over for pi over 2. And again, that's just my graph paper is small. There's no significance to the 2. I just want more space to graph. And then I usually, same thing, I usually have the 1 unit up and pi over 2 to the right. So this would be a negative 2 pi. And then 1, 2, 3, 4, this would be at 2 pi. All right, this is pi, 3 pi over 2, 2 pi. So that'll give me a nice 2 periods if I graph that. I might need more, but we'll figure it out. Okay, so what's going on with this graph? Well, I know that it has an amplitude of 3, which means it's vertically stretched 3. I know it has flipped upside down. So flipped over the x-axis. I know it has shifted to the right pi over 2. And I know it has shifted up 1, which is a lot. But if we just locate the new location of the xy axis, then I don't have to worry about this and this when I'm graphing, because that's all going to be, sorry about that, that's all going to be established. So here we go. I'm moving it to the right pi over 2. Let's change my color here. And up 1. So my new x and y axis would be located right here. Add dots if it helps you. It helps me quite a bit. All right. If it helps you also, go ahead and put the sine wave in there without changing it, without doing the negative 3. So regular sine starts at 0 and then moves up 1 unit. So we'd be up at 2. So I'm going to be here. And then 2 boxes over, 2 boxes over, 2 boxes, 2 boxes. Nice and simple. All right, so regular sine in the new location would look like this. So what am I going to do with it? I am going to flip it and make it 3 times as tall. So instead of going over to pi and up 1, I'm going to go over to pi and down 3. In our case, 6 boxes, though. 1, 2, 3, 4, 5, 6. Then I'm going to go over pi over 2, and I'm going to be back at 0. I'm going to go over 2, and I'm going to be, instead of at the low point, right, I'm going to be at my high point. 1, 2, 3, 4, 5, 6. So 3 units off of the break even, the middle here. And then I'll be back at 0. Over 2, back down to the low. Over 2, back down, up to the middle. Let's see here. I'm on my way up, over 2 and up to the high point. Over 2, down, back to the middle. Over 2, 1, let's see at the low point here. And just for fun, we'll be back here. And so you will see that where my low was going to be on sine, right at 0, we're now at a high point. And that makes sense because we have reflected it. All right, and that's how we would graph that. Well, let's keep going. We got more to do. We're going to break this in class into 2 days, but I'm going to make this into 1 video. We are now going to explore, if my thing starts working, there we go. We're going to explore what does cosine look like. So let's use our same table of values idea, but this time let's just stick with the x and y axis values. So what I mean is, let's go ahead and make our theta and f of theta. And let's find the cosine of 0. So cosine of 0 is 1. And let's do pi over 2. And that would be 0. And let's do pi, and that would be negative 1. And let's do 3 pi over 2. That's 0. And then back all the way around to 2 pi. And we'd be back at 1. So again, all I'm doing is I'm just thinking about my unit circle and the coordinate points here, here, and here. Again, I could fill out the details, but since cosine and sine are very much related, it's going to do the exactly same thing that we just saw. And so I'm just focusing on the highs and the lows. So let's go ahead and take a look. Here's my theta axis. Here's my f of theta. This time, cosine, let's see, let me establish my scale. So I'm going to go with 2 boxes again for 1 and 2 boxes for pi over 2. So this would be pi, 3 pi over 2, and 2 pi. So cosine of 0 is 1. Pi over 2 is 0. Pi is negative 1, 0, and positive 1. And so what we have, if we just stick between 0 and 2 pi, is a graph that looks like this, where, just to drive home the point, this part corresponds to quadrant 1. This part corresponds, wrong color. That's the cosine values in quadrant 2. Here are the cosine values in quadrant 3. And of course, cosine in quadrant 4 is positive. And so then we have back to positive values. And if we just keep going with this pattern, we will get the same value. So I go over another pi over 2, and I'm back to 0. Another pi over 2, I'm down to negative 1. Back to 0, and then this would be 4 pi. So we can see that the graphs look basically the same. We're just kind of starting them in a different location. So what would you say the period of cosine is? And even though it doesn't start at a nice pretty 0 and end at 2 pi, we hopefully do see that the period is still 2 pi. Because from this high point, for example, to this high point is a distance of 2 pi. From this 0 to this 0 is a distance of 2 pi. All right. So then one cycle of cosine, again, just like sine, it's broken up into 4 parts because it comes from the 4 quadrants. So we just got to focus on the high, the 0, the low, the 0, and then back, start over again. So we're going to just have a period that looks like this. There's 2 pi. There's halfway. There's 0. And we have 1 and negative 1. So if you can graph sine, you can graph cosine as long as you start it in the right spot. All right, we're not going to do as many examples. In fact, I think we're just doing one example. So let's go ahead and see what's going on with cosine here. Let's realize it's going to move up 3. So let's account for that in our coordinate system. So I'm going to move my axis lower here. Give myself room. And I'm going to stick with my pattern of going 2 boxes. So there's pi over 2, pi. There's 2 pi. There's 3 pi. And 4 pi. And let's do some negative. So that should be negative 2 pi, negative pi. And we'll stick with 1 and negative 1. All right, what's going on with this graph? It is moving up 3. It is shifting to the negative direction to the left, pi over 2, and it's flipped upside down. So let's establish our new location of the x and y axis. We're going to move it over to pi over 2, which is this first tick mark, and then up 1, 2, 3. So we are going to be looking at our x and y axis right here. And since we're brand new at this, what I would highly recommend is let's put the parent function down right now in this new location. And we know that the parent function starts at 1. So we're going to be up 1, and then we're coming down to 0, and then we're going to be down and 0, and high and middle and low. All right, so this is the parent function. So there's our parent function in the new location, but the only thing we're going to do to this is we're going to flip it over. So our graph is actually going to be the green one, which is just going to be us. Instead of starting at a height of 1, I'm going to start at a low point. Zeros are going to stay zeros. And then this is going to go up. That's going to stay a 0. We're going to be down, stay 0, up, 0. We didn't change the amplitude, so our graph is just the green one here. And we should be able to graph it without doing the parent function, but since this is our first one, that seemed like a good idea. All right, we're going to end the video there. You should now know how to graph sine and cosine, and we'll keep playing with transformations of those over the next couple of days. All right, we'll see you in class.